We have a massive plastic problem, right? We're practically drowning in it. But what if the answer wasn't some new high-tech invention, but something that's been evolving right under our noses? Today, we're going to dig into the amazing story of a plastic-eating enzyme. Seriously, this could change everything. I love this quote. Nature is fighting back. Eats plastic for breakfast. It just perfectly captures the whole vibe of this story, doesn't it? The idea that nature itself might be cooking up a solution to our mess. But is it going to be fast enough? That's the big question. Okay, so before we get to the cool science, we really need to wrap our heads around just how big this problem is. Because when I say plastic overload, I mean it's almost hard to even imagine. Take a look at this number, 9.2 billion tons. That's how much plastic we've made since what, the 1950s? To give you an idea of what that means, it's like more than 1 ton of plastic for every single person alive right now. And almost all of it is now just waste. And here's the really wild part. Where does it all go? Well, look at this. A whopping 79% is just sitting in landfills or, even worse, out in the environment. Only 9%, has ever actually been recycled. So you have to ask, why is that number so low? Well, here's the thing. Our standard way of recycling, what's called mechanical recycling, has a really big problem. It's more like downcycling. You see, every time you melt down plastic to reuse it, the material gets weaker. The quality just degrades. So your crystal clear water bottle doesn't become another water bottle. It becomes, say, carpet fiber. And after that, it's pretty much destined for the landfill. It's not a closed loop at all. It's a dead end. But then, something totally unexpected happened. Right in the middle of all this plastic mess, scientists stumbled upon a glimmer of hope. And it wasn't a new machine or a chemical process. It was something alive. So, picture this. It's 2016, and a team of scientists in Japan is scooping up mud from outside a plastic bottle recycling plant. And in that mud, they find a totally new kind of bacteria. And this little guy, Ideonellus sakaiensis, had actually evolved right there to do something incredible. It was literally eating plastic for lunch. It was its main food source. So how does it do it? Well, the bacteria creates this amazing little biological tool, an enzyme. They called it PETase. And you can think of it like a pair of super tiny molecular scissors. It's specifically designed to find PET plastic, the stuff our soda bottles and lots of our clothes are made of, and it just snips it apart. And it's not just one step, it's this brilliant 1-2 punch. First, the PETase enzyme comes in and breaks the big plastic molecule into a smaller chunk. But then, a second enzyme, called MHETase, swoops in and finishes the job. It breaks that smaller piece all the way down into its original fundamental building blocks. It's a total deconstruction, back to square one. Okay, so finding this enzyme was a total game changer. But there was one problem. In its natural form, it was pretty slow. I mean, way too slow for our mountains of trash. So for this to actually work in the real world, scientists had to take what nature gave them and basically put it on steroids. And you won't believe how fast things move from there. I mean, it's just incredible. The bacteria was discovered in 2016. Just 2 years later, in 2018, scientists had already engineered a better, faster version. By 2020, they created something called PETase, a super enzyme that could chew through plastic in hours, not weeks. And now, today, companies are actually starting to scale this up for industrial use. That's lightning fast for science. So all of this crazy fast innovation is driving towards one big, beautiful dream, creating a truly circular plastic economy. Something that honestly seemed like pure fantasy just a few years ago. Remember those original building blocks we talked about? Well, this enzymatic process breaks the plastic all the way back down into those pure raw materials, TPA and EG for the chemists out there. It's like hitting the factory reset button on the plastic. And this is where the real magic happens. You can take those basic building blocks and make brand new virgin quality plastic. Plastic that's just as good, just as clear as plastic made from oil. There's absolutely no loss in quality. No downcycling, you can just do it again and again and again. It's a perfect infinite loop. So let's just compare these methods side by side. Your standard mechanical recycling, it degrades the plastic. Other chemical methods, yeah, they can work, but they often need tons of heat and pressure, which means tons of energy. But this enzymatic recycling, you get that perfect virgin quality plastic, but at low temperatures using less energy. And get this, It's way better at handling plastics that are contaminated with things like leftover food or dyes. Okay, this all sounds amazing, right? Like, we've solved it. But of course, it's not quite that simple. Taking this incredible science out of the lab and using it on our global mountain of trash, well, that comes with some pretty serious hurdles. The biggest challenges are really about scale and cost. First, can we make these enzymes cheap enough? Because right now, making new plastic from oil is still super cheap. Second, can we make the process fast enough to keep up with the insane amount of plastic we throw away every single day? Then you've got things like dyes and other additives in the plastic that can gum up the works. And finally, these enzymes are delicate. Keeping them alive and happy in a giant industrial-sized tank is a really, really tough engineering problem to solve. So that brings us to the million-dollar question. Is this the silver bullet? Is this one enzyme going to solve our whole plastic nightmare? Well, the honest answer is no, not yet. You see, PETase is a specialist. Think of it like a key that is perfectly designed for one specific lock, the PET plastic lock. It's completely useless on other types of plastic, like polyethylene, which is what your milk jugs and shopping bags are made of. Those have a totally different chemical structure, a different lock, that needs a whole different key. But here's why PETase is still so revolutionary. It's the proof of concept. It showed us that this is even possible. It's kicked the door wide open to a whole new way of thinking about how we fight plastic pollution. And now, thanks to the success with PETase, the hunt is on. Scientists all over the world are searching everywhere, from compost heaps to the bellies of waxworms, looking for new enzymes. They're even using AI to design them from scratch, all in an effort to find the keys for those other tough plastics, like polyurethane and polyethylene. And that brings us full circle. The science here is just mind-blowing. The potential is absolutely there, but the clock is ticking, loudly. Nature has handed us a clue, a possible way out of this mess. The real question is, can we run with it? Can we scale it up and get it out into the world before our oceans completely choke on our waste?